discussed regarding design equations for horn antenna. Okay, so the electromagnetic horn. Okay, so this is our horn antenna. Okay, so this is our horn antenna. So this is E plane view. Let us consider this is E plane view. E plane view. This is E plane view. Okay, so the electromagnetic horn produces uniform phase shift, phase front with a larger aperture as compared to with waveguide. So because of this, the directivity increases. Consider an imaginary apex. So this is, let us consider this is my imaginary apex of the horn. Assume that there exists a line source which radiates cylindrical waves. The constant or uniform wavefronts are cylinders. The wave propagates in the direction radially outwards at any point on the aperture, the phase is different than at the origin. The phase is different than at the origin. So the reason of the difference in phase is that the wave traces a different distance from apex to the aperture. Let delta is the difference. So this is the small difference. Okay, so if we assume like this is the small difference. Okay, this is the small difference. Okay, so from this diagram, so this is, let us consider this triangle. Let us consider this triangle. Okay, so this is my triangle. Okay, so the total length is h. Okay, so what happened from here to here? It is h by 2. So this side is h by 2. So up to here it is rho, and from here to here it is delta. Okay, and this is also rho. Okay, so what is the formula for the cos theta? Cos theta is equal to, if you observe, if you consider this, cos theta is equal to, cos theta is equal to, what is the formula? Adjacent side. This is my adjacent side rho. This is my, so this is my diagram rho. Okay. So cos theta is equal to, what is the adjacent side? The adjacent side is, rho. Okay, so this is rho. This is rho. From here to here also, this is rho. From here to here it is also rho. Okay, so it is rho by. So what is the hypotenuse? It is a combination of rho plus delta. It is a combination of rho plus delta. So that is rho plus delta. Okay. So similarly, what is the formula of the tan theta? Tan theta means, what is the formula of the tan theta? Opposite side by adjacent side. What is the opposite side? It is h by 2. What is the adjacent side? It is rho, which is h by 2 rho. H by 2 rho. So let us consider this is 1, 2 from 1. What is the expression for theta? Theta is equal to cos inverse of rho by rho plus delta. Similarly, from 2, what is the expression for theta? Theta is equal to tan inverse of h by 2 rho. H by 2 rho. Okay. So these are the angles. Okay. So from the above triangle, from the above triangle, so you can write it as hypotenuse. Okay, rho plus delta. So what is the value of this one? Rho plus delta is equal to adjacent square root of opposite square h by 2 whole square plus rho square. Okay, so therefore squaring on both sides, rho plus delta whole square is equal to rho square plus h square by 4. So it is rho plus delta whole square is equal to rho square plus delta square plus 2 rho delta is equal to rho square plus h square by 4. So rho will get cancelled. Okay. So if you observe in this diagram, the value of this delta is very, very less. The value of this delta is very, very less. Okay, so since delta is very small, delta is very small, delta can be neglected. Delta can be neglected. So delta square also neglected. Therefore, 2 rho delta is equal to h square by 4. Okay. So from this, rho is equal to h square by 8 delta. It's very, very important. Rho is equal to, so what is this rho? This is nothing but this from here to here. This distance is called as rho. So distance is called as rho. So therefore, rho is equal to h square by 8 delta. Rho is equal to h square by 8 delta. Okay, so similarly, let us consider for an optimum form for an optimum plane form. For an optimum flare form, the half power beam width, the half power beam width can be approximated as half power beam width can be approximated as theta h is equal to 67 degrees lambda by ah. Okay, and similarly, theta e is equal to 56 degrees lambda by AE. What is this AE and AH? AE is equal to E plane aperture in meters. What is this AH? AH is H plane aperture in meters. H plane aperture in meters. Okay. So, for example, if assuming that there is no loss, the directivity in effective area is given as directivity D is equal to the formula 4 pi A by lambda square. So it is 4 pi into effective area means I am writing it as aperture efficiency into A. So effective area, I can write it as aperture area into A. So what is this A? A is effective area. A is physical area. A is physical area. Not this epsilon AP. It is aperture efficiency. Aperture efficiency means the ratio of effective area to physical area. Aperture efficiency means the ratio of effective area to physical area. Aperture efficiency means aperture efficiency. So it is the ratio of effective area to physical area. Always its value is less than 1 because physical area is always more when compared to the effective aperture area. Effective aperture area. So therefore, directivity is equal to 4 pi into sigma AP into APR. AP stands for physical area. AP stands for physical area. AP by lambda square. AP by lambda square. So for a rectangular horn, for a rectangular horn, so see here, this is my rectangular horn. So what is the aperture area? Aperture area is nothing but multiplication of AE into AH. Okay, so for a rectangular horn, physical area is equal to AE into AH. Okay, so for example, if the aperture is in circular shape, it is the formula is pi s, pi a square. Okay, so for a rectangular aperture area, the AP is equal to AE into AH. Okay, so A into AP into AH. Okay, so aperture area. So if aperture efficiency epsilon AP is equal to 0.6, then the directivity of a rectangular horn is given as, what is the formula? D is equal to 4 pi into epsilon AP into AP by lambda square. So it is 4 pi into epsilon, it is 0.6 AP by lambda square. So that is 75 into physical area by lambda square. So, okay. So in dB it can be expressed as equal to 10 log base 10 7.5 is 7.5 AP by lambda square. So similarly, if for conical horn, what is the only difference? For a rectangular horn, the physical area is multiplication of A into AH. But for conical horn, since the physical area is circular, the physical area will becomes pi r square. Pi r square. That is the only difference. Okay, so in the previous case for the rectangular horn, AP, the physical area is A into AH. But for conical horn, the physical area AP is equal to pi r square. Physical area is equal to pi r square, where r is radius of the aperture. Radius of the aperture, where r is radius of the aperture. That is radius of the aperture. Okay, so this is the brief introduction regarding hornet. Okay, so the main purpose of the hornet, they will act as a primary feed for various reflector antennas. Reflector antennas. So that is the main purpose of the hornet. That is the main purpose of the